And so in the previous video, we determined the determinant of this matrix, and we found that the determinant of A was equals to 1, 1, 0. And therefore, the next thing that we are going to do here is to determine the cofactor of each figure inside here. So let's assign, let's say, the positions with sign. You know that this will give this plus, minus, plus, minus, plus, minus, plus, minus, plus in this case. So these signs eventually help us when we determine the cofactors of each figure. So out of that, let's determine the cofactor of 1, and we shall be placing them in here. So for cofactor of 1, if we say the cofactor of 1, so we are going to say for 1, we are going to determine this and say that we are going to remain 4, 7, 2, 8. So out of that, we determine this in the form of determinant, and therefore we're going to get something that's going to be 4 times 8 minus 14. So this is going to be something that's going to be 32 minus 14, and therefore we're going to get something that's going to be, and so this is going to be 18 in this case. So the cofactor of 1, we've got 18, but now the sign on 1 is positive, and therefore this is positive 18, so we put it in the position of 1. And now let's determine the cofactor of 4. And therefore for 4, cofactor of 4, in this case we shall have 2, 7, 9, and 8. So out of that, this is going to be giving us something that's going to be 2 times 8 minus 9 times 7 in this case. Therefore this is going to be 16 minus 9 times 7, and this would be 63 in this case. So if we make the difference, you find that here this would be equals to negative 47 in this case, and therefore this is the cofactor in this position. But now, and since we have got negative 47, so the next thing is, that's like, if you look at 4, it has a negative sign on it. Therefore if a negative meets a negative, we get a positive, so this becomes a positive 47. Now let's get that of 3 in this case. And now for 3, we shall get it by saying that we shall have the determinant of 2, 4, 9, 2. And so this will be equals to 4 equals to times 2 minus 9 times 4, which will be 36 in this case. So if you subtract this, you're going to get something that's going to be, this is going to be negative 32. Now the sign in the position of 3 is a positive, and therefore this will be negative 32 in this case. Okay, now let's get that of 2. Now for 2, you find that this will be now to get of these 2, that means that we are going to have 4, 3, yes, and 2 and 8, yes. So 4, 3, 2, 8. So this would be equals to, we are going to have 4 times 8 minus 3 times 2, yes. So that means that you're going to get something that's going to be, this will be 32 minus 6 in this case, and therefore you're going to get something that's going to be, you're going to be getting 26 in this case. So now you look for the sign on 2, which is a negative in this case, therefore you assign it here. So that means that you're going to have negative 26 in this case. And now let's get the cofactor of 4. Now for 4, we're going to say 4, we're going to get the cofactor in terms of saying that if you're having 4, it means you're remaining with 1, yes, 3, 9, and 8, yes. So out of that, we're going to have something that's going to be equals to 8 times 1 minus 9 times 3. So out of that, if you work out this, you're going to have something that's going to be 8 minus, we're going to have, this is going to be 27. So after all, you're going to have, so here we're going to have negative 19. Now be aware of the sign on 4. It is a positive, and therefore we maintain it with its negative. So we're having negative 19 in this case. So now let's look for the cofactor of 7. So let's remove this. Now that of 7, of course, of 7, we are going to get it from, we're going to get the determinant of, this is 7, so that means we're having 1, 4, and 9, 2. This will be equals to 2 times 1 minus 4 times 9. So out of that, you subtract this, you're going to get 2 minus, this is going to be 36, which will give me a negative 34 in this case. Now the sign on 7 is negative, therefore this becomes a positive, and therefore we're going to have positive 34. Okay, now let's look for that of 9. And now for 9, you're going to have something that's going to be 9, we are going to have 4, 3, 4, 7. This is going to be 4 times 7 minus 3 times 4. And so this is going to be equals to 28 minus 12, which would be equals to, I'm going to have 1, which will be 16. Now the sign on 9 is a positive, therefore this would be a 16 with its sign. Therefore let's determine that of 2. And now for 2, this will be from, this is 2, that means that we are going to have 1, 2, yes, and 3, 7. So this, I'm going to get this and say this, I'll get 1 times 7 minus 3 times 2. So out of that, this will be equals to 7 minus 6, which would be a 1. But the sign on 2 is a negative, and therefore this will be negative 1. And so the next step is that of 8. So that of 8, for 8, I'll get it from, if you look at 8, that means that I'm having 1, 4, 2, 4, and therefore I'm going to get something that's 4 times 1 minus 4 times 2. Therefore this is 4 minus 8, which would give me a negative 4. But the sign on 8 is positive, and therefore I retain the sign. This is a negative 4 in this case, a negative 4. So out of that, even if I remove this and I remove this, I'm done using this. So now this is the matrix of cofactors, the matrix of cofactors only. Yes, the cofactors of the previous matrix that we have used. Let's like step by step up to here. So if I out of that, we go this, but we're using the principality of the signs. Sort of that. Now, having go this, the next step is we are going to do transposing. Yes, transposing this matrix. Therefore, Transposing just means converting a row into a column. So what I'm going to do here, I'm going to transpose this, of which if I'm to transpose this, so this is going to be transposing. So the transpose of this is going to be, I'm going to have 18, 47, negative 32, yes, negative 26, negative 19, so 34. And so the next one will be 16, negative 1, negative 4. And so this is what we refer to as the adjoint. The adjoint. So now we have reached the step of determining the adjoint, but remember from the formula that inverse of A was equals to the adjoint divided by the determinant of A. And so this is going to be this. We have the adjoint, which is this. So we have our determinant, which was 110. So that's what we're going to do here. So we are going to say this is going to be 1 all over 110 into, then we are going to have 18, negative 26, 16, 47, negative 19, negative 1, negative 32, 34, negative 4. And therefore, if we multiply this throughout, this will give us the inverse of A. If we work out this, this will give us the inverse of A. I'm saying that. So of that, through what we did first, we got the determinant. Now, after getting the determinant, we went to determine the cofactors. After determining cofactors, we went to what we call transposing. Now, transposing is just the making of the rows to become columns. Yes. Now, out of that, then we went to the final formula, which was after transposing, we got the adjoint, what we call the adjoint. Now, after the adjoint, then we divided the adjoint all over the determinant of A. So this is the steps you follow when determining the inverse of a 3x3 matrix. Thank you for watching. Don't forget to like and share this video. See you next time.